Then minus Kt is equal to log to base E. I'm doing the log here. इसी को मैं same thing I'm writing again. Minus same thing I'm writing again. So At upon A0 is equal to e raised to minus Kt, or concentration of At is equal to concentration of A0 into minus Kt. This is called exponential form of rate law. Okay. So this is exponential form of rate law. At At, concentration at time t is equal to concentration at time 0 e raised to minus K. Okay. So this was the integrated rate law for the first order reaction. Now we'll see further half-life period. Half-life period. Half-life period for first order reaction. I want to know whether do you know the meaning of half-life period? Do you know the meaning of half-life period? What is half-life period? Half-life period का meaning क्या है? Suppose we have A0 as 100 gram, initial concentration 100. ये 100 ग्राम को 50 ग्राम बनने के लिए जो टाइम लगेगा, that time is called as a half-life period. 50 ग्राम को उसका हाफ होने के लिए जो टाइम लगेगा, that is called half-life period. 25 का उसका हाफ होने के लिए जो टाइम लगेगा, that is called as a half-life period. Time required to convert 100 to 50 is T half-life period, and that is also equal to time required to convert is also T half, and that is also equal to AB T half, and ये तीनों टाइम क्या रहेंगे? इक्वल रहेंगे. तीनों टाइम इक्वल रहेंगे for any particular reaction. The time required for half the initial compound, for half the initial reactant to convert into product is called as a half-life period. So definition of half-life is, definition of half-life उसका definition क्या है? Half-life period is a time required half-life period of a reaction is a time required for the reactant concentration to fall to 1/2 of its initial value. Of its initial value. It is denoted by T-half. यानी 100 ग्राम है, 100 का हाफ होने के लिए जो टाइम लगता है, that is called as a half life period. या 50 को जो हाफ होने के लिए टाइम लगेगा, that is called as a half life period. 50 का 25 का हाफ होने के लिए जो टाइम लगेगा, that is called half life period. And all the half life period is equal for a particular reaction. हर reaction का, for a particular reaction, the half life period is a constant. We are going to derive expression for the half life period of first order reaction. Derivation for expression for half life period. From integrated rate law for first order reaction. What is it? K equal to 2.303 upon T log to base 10 concentration of A0 upon concentration of AT. Right? Concentrate. To convert A0 to A0 by 2, उसका आधा होने के लिए time required is called as T-half. A0 को A0 का half होने के लिए time required is T-half. So we say when T is equal to T-half, AT will be equal to A0 by 2. When T is equal to T-half, AT will be equal to A0 by 2. So we can write K is equal to 2.303 upon T-half log to base 10 A0 upon A0 by 2. T-half is equal to 2.303 upon K log to base 10 2. Two 2.303 log to base 10 2 is 3010 upon K. So T-half is equal to 0.693 upon K. This is the expression for half-life for first order reaction. Half-life is independent of initial concentration. Half-life is independent of initial concentration. For first order reaction. T half is 0.693 upon K. Half-life is independent of initial concentration for first order reaction. So this was the derivation for the half-life. Now, next what we are going to see is the graphical representation of first law. Graphical representation for first order reaction. And how we can show first order reaction graphically. So there are three ways we can show the graph for the first order reaction. In three ways we can express the first order reaction graphically. First, consider a first order reaction that means rate law in differential form will be how much? Will be minus dA upon dt equal to Ka. This is the differential form. If you write this minus dA upon dt equal to K into A AT plus 0. So you'll get this is Y, this is M, this is X, this is C. Y is equal to mx plus c is the equation of a straight line, but c is 0. So if you plot minus dA upon dt on the y-axis and on the x-axis, if you take AT, that is concentration, you'll get a straight line passing to origin, and the slope of this line will be equal to m, because this is a slope. C is 0. So y is equal to mx plus c. C ka value is 0. So that means it will pass into origin. So this is one way of expressing first law, first order reaction in graphical form. That means we plot. What is this? This is nothing but a rate. If you rate against concentration, you get a straight line passing to origin. So this is one of the way of expressing first order reaction in graphical form. In your textbook, there are three ways of representing. I am taking the second way. From integrated rate law equation, rate law for first order, what it is? A0 upon AT. KT upon 2.303 equal to log to base 10 A0 minus log to base 10 AT. Okay. If you rearrange it, log to base 10 upon 2.303 into T plus log to base 10 A0. If you see this is also equation of a straight line. This is Y, this is M, this is X, this is C. Y is equal to mx plus C. But M ka value is negative, minus K upon 2.303. That is the slope. So if you plot a graph of log to base 10 AT against T, that is X, you'll get a straight line with a negative slope. And the K slope will be minus K upon 2.303. And this is C, that is Y-intercept. It will be log to base A0. This is Y-intercept. So this is a second way of representing graphical representation of first law of first order reaction. Now let us see the third way of representing the first order reaction. ग्राफिकल रिप्रेजेंटेशन दो फॉर्म तो देखे हमने. ये पहला फॉर्म है, ये दूसरा फॉर्म है. आप तीसरा फॉर्म देखेंगे. फ्रॉम इंटीग्रेटेड रेट लॉ for first order reaction, what do you get? K is equal to 2.303 upon T log to base 10 A0 upon AT. A0 upon AT. If I arrange it, KT upon 2.303 equal to log to base 10 A0 upon AT. A0 upon AT. If we arrange it in proper way, log to base 10 A0 upon AT is equal to K upon 2.303 into T plus 0. This is Y. This is M. This is X. This is C. Y is equal to mx plus C. If you plot log of A0 upon AT on the y-axis, and x is t, the c is 0, that means this line will be passing to origin. The slope of this line will be equal to k upon 2.30, k upon 2.3. So this was first order reaction. Now we are going to see zero order reaction. Zero order reaction. What a zero order reaction? By a definition, the reaction in which rate of reaction is independent of the reactant concentration is called zero order reaction. Reaction in which rate of reaction is independent of the reactant concentration is called as zero order reaction. We'll take some example. Example number 1. Decomposition of ammonia on platinum metal. Decomposition of ammonia on platinum metal. Reaction is NH3 giving you N2G, (3H2G), and this takes place in presence of PP. The rate is equal to K ammonia raised to 0. That means it doesn't depend upon concentration of ammonia. Power uska 0 hai. Therefore, it is a zero order reaction. Example 2. Decomposition of nitrous oxide on platinum catalyst. Decomposition of nitrous oxide on platinum. So it will be N2O giving you N2 plus oxygen. So rate here is equal to K concentration of nitrous oxide raised to 0. So it is independent of concentration of nitrous oxide. So these are the two examples of zero order reaction. Now we are going to derive integrated rate law for the zero order reaction. Derivation of integrated rate law for zero order reaction. Rate law for zero order reaction. Consider a zero order reaction Consider zero order reaction A giving you product. Rate is equal to minus dA upon dt is equal to K A raised to 0. This is in which form? Differential form. Differential form. Now we'll convert it to integrated form. Rearranging it, you get dA upon A. Sorry. So it is dA upon dt is equal to K. Because A raised to 0 is 1. A raised to 0 minus dA is equal to KT, or dA is equal to minus KT. When concentration of A is equal to A0, when concentration of A is equal to A0, T is equal to 0. And when concentration of A is equal to AT, T is equal to T. So if we integrate this, dA between the limits A0 and AT equal to minus integration minus KT 0 to T. Integration of dx is equal to x. Integration of dx is equal to x. और ये भी मैंने गलत लिखा. It is dt dt dt. So integration of this will be a upper limit a0 80, lower limit a0 minus k integration of dt 0 t. So this is 80 minus a0 is equal to minus k. Integration of this is t minus 0. So you get 80 minus a0 is equal to minus k into t. So kt is equal to a0 minus 80, or k is equal to a0 minus 80 upon t. This is integrated rate law equation for the zero order reaction. A0 minus 80 is equal to kt. Kt is equal to A0 minus 80. This is integrated rate law equation for zero order reaction. For zero order reaction. Okay. Now we'll see half-life period. जैसे फर्स्ट ऑर्डर के लिए वैसे हाफ लाइफ पीरियड इसका भी निकालेंगे एक्सप्रेशन फॉर द हाफ लाइफ पीरियड. Now I am not repeating what is half life period. Expression for half life period for zero order reaction. From integrated rate law equation, for zero order reaction, what is that? Kt is equal to A0
minus 80.
80. Okay. When T is equal to T half, that means half life period, 80 will be equal to half of initial. When T is equal to T half, 80 will be equal to A0 upon 2. So substitute that. K is T half is equal to A0 minus A0 upon 2. So K T half, and this is equal to A0 upon 2. A0 minus A0 upon 2 is A0 upon 2. So T half is equal to A0 upon 2K. This is a half-life period for zero order reaction. Half-life period expression for zero order reaction. Now we'll see graphical representation for zero order reaction. जैसे फर्स्ट ऑर्डर का है वैसे ही हमको सेकंड ऑर्डर जीरो ऑर्डर में देखने का है. Graphical representation for the zero order reaction. एक ही ग्राफिकल रिप्रेजेंटेशन है. Graphical representation for zero order reaction. From integrated law, for zero order reaction, what is that? क्या मिला हमें? What is that?
KT
KT is equal to A0 upon minus T. KT is equal to A0 minus AT. If I arrange it, AT is equal to minus KT minus plus A0. This is Y. This is M. This is X. This is C. So Y is equal to MX plus C. So if you plot, Y means 80 on the y-axis, X, T on the x-axis, you get a straight line with negative slope, where this part is A0 and the slope is minus K. So this is graphical representation of zero order reaction. Now we see next pseudo for zero order reaction. Pseudo first order reaction. Pseudo first order reaction. Pseudo first order reaction. Pseudo का मतलब क्या है? False. Actually, there are some reaction which are of higher order, but they become first order. Reactions are of higher order, but they become first order by taking one of the reactant in excess. Certain reactions which are expected to be of higher order but behave as first order reaction. first order reaction by taking reactant in higher concentration. For example, if you take A plus B is equal to C, you see the rate law for this reaction is K, A and B. That means order is 2. But if you take concentration of A in excess, if A, concentration of A is in excess, if I said, then the rate becomes K concentration of B. It doesn't depend upon A. So reactions of a higher order but follow first order because some of the reactants are taken in excess. So here in this particular reaction, A and B are the reactant. Rate law is rate is equal to K A raised to 1, B raised to 1. That means order of the reaction is 2. But if you take A in excess, A is taken in excess concentration, then the rate will depend only upon B. It will not depend upon A. So such reactions which are of higher order but behave as a first order are called as pseudo first order reaction. Are called pseudo first order reaction. Are called pseudo first order reaction. And I've given you the explanation for that. Certain reactions which are expected to be of higher order but behave as a first order reaction by taking a reactant in higher concentration are called as pseudo first order reaction. An example I gave you, A plus B give you 2C, rate is equal to K A raised to 1, B raised to 1, order is 2. If A is in excess, rate will be KAB. I'll give you certain example, one example or two examples. Consider acidic hydrolysis of methyl acetate. Acidic hydrolysis of methyl acetate. Ester. Consider acidic hydrolysis of methyl acetate. Example, CH3, COOO, CH3 plus water in presence of acid, you will get CH3, COOH plus methyl alcohol. This is aqueous. This is aqueous. This is liquid. This is aqueous. The rate law of this reaction is rate is equal to K concentration of methyl acetate and water. So reaction is of second order. Reaction is expected to be second order.
Allahu Akbar, Allahu Akbar.
Second order
Allah.
because there are two reactants. This is one and this is second. So 1 plus 1, that is 2. So the second order reaction. But it follows first order reaction. It follows first order reaction. दिख रहा है second order, but it follows second order, first order reaction. How come that? Here, in this reaction, water L is in excess. It is in excess. And anything in its excess, and if there is a change in its concentration, it doesn't affect it. For example, if you go to the sea, for Chowpatty Sea, Chowpatty, there is a sea, plenty of water is there. And if somebody says that I can reduce the volume of this water, we laugh at it. How can you reduce the volume of the sea water? But he will show how you can change the volume of the sea water. What he'll do, he'll take one small cup and remove a cup of water from the sea and drink it. Actually, theoretically, he has reduced the water by a cup. But that reduction is negligible comparing the large quantity of water in the sea. कोई बोलेगा कि मैं सी का वाटर कम कर सकता हूं, एक कप पानी निकाला और पी लिया. Actually, he has reduced, but that reduction is negligible comparing the huge amount of water in the sea. Same thing is applicable here. Here, water is in excess. उसका concentration change हो रहा है. Water is used up, but amount of water used up is negligible compared to the water present. So in this reaction, water is in excess. The change in concentration of water is negligible. Therefore, we say rate is equal to K into acetate, methyl acetate, into another constant K dash. Water is negligible. Therefore, concentration of water is taken to be as K, a constant. So rate is equal to K into K dash into concentration of methyl acetate. And rate is equal to K into K dash is equal to K double dash. तो यह रेट लॉ बदल गया. अभी पहले 2 था, अब रेट लॉ 1 हो गया. पहले 2 रिएक्टेंट थे, नाउ द ऑर्डर इज कम 1. Therefore, here the rate depends only upon concentration of methyl acetate, not on water, not on concentration of water. So this is the pseudo first order reaction. Therefore, it is called pseudo first order reaction. Pseudo first order reaction. Second example which I can give you is hydrolysis of cane sugar. Hydrolysis of cane sugar. Cane sugar C12 H22 O11 on hydrolysis in presence of acid, you get C6 H12O6 plus C6 H12O6. Rate law is equal to K, concentration of cane sugar. This is cane sugar. O11 into concentration of water. But concentration of water is in excess. Therefore, rate is equal to K into C12 H22 O11. It is a pseudo first order reaction. It's a pseudo first order reaction. So this was the pseudo first order reaction. So we have completed the order of reaction. Now we'll be doing molecularity of the reaction. Molecularity of the reaction. What is molecularity of the reaction? Coming.
सर हो गया
No, I'm coming. To understand molecularity of the reaction, we must first know what do you mean by elementary reaction? Elementary reaction. Elementary reaction. A reaction which that takes place in one step. The reaction that occurs in single step and it cannot be further broken down is called as elementary reaction. A reaction which takes place or which occurs in single step and cannot be broken down further. And cannot be broken down further. इन्हें वापस उसको और सिंपल नहीं बना सकते. It's called elementary reaction. Elementary reaction.
We have another lecture, sir.
Example. Ozone split into oxygen plus O. It is an elementary reaction. Second example, CH3, CH2I, it forms CH2 double bond CH2 plus HI. This is also elementary reaction. The call as what? Elementary reactions. Now, what do you mean by molecularity reaction? Molecularity of the reaction. Number of molecules taking part in an elementary reaction is called as the molecularity of the reaction. Number of reactant molecule, molecularity का definition, number of molecularity of a reaction is defined as number of reactant molecule involved in an elementary reaction. For example, if you take this reaction, O3 giving you O3 O3 plus O giving you 2O2. How many molecules are involved? 2 molecules. So it is a bimolecular reaction. If we take this one, C2H5I giving you C2H4 plus HI, एक ही molecule involved है, unimolecular reaction. If we take this one, 2NO2 give you 2N.
Can we stop, sir? We have a lecture at 7:30.
We have got lecture. Yeah, we'll stop it. 2NO plus O2. This is unimolecular reaction. Unimolecular reaction. So the number of molecules which are involved in an elementary reaction is called as molecularity. It can be unimolecular if one molecule is involved. It can be bimolecular if two molecules are involved. It can be trimolecular if three molecules are involved. So depending upon number of molecule reaction, we are calling as different. So that was the molecularity. Okay, chal, we stop here.
Thank you, sir. Bye, sir.
Bye, sir. Thank you, sir.